now I forgot my chalk. Oh. Good morning, fellow mathematicians. Welcome back to another video. Today we are going to talk about yet again another rule of exponentiation, and for me it's the most important exponentiation rule there is, because if you know about this exponentiation rule, you know about how to deal with fractions way better. Also, you are going to be able to solve square root equations, for example, Rudy boys, in some way. This is something that you can do if you know about this rule. And what we are going to do today is we are going to raise exponentials, well, to a power. Meaning what we are going to do is we are going to raise some a to the nth power, an exponential, to the mth power yet again. N and m could be anything. 0, 1, negative 112, etc., pi, whatsoever. They could be everything. We are going to go ahead and use examples yet again to derive this rule. It's going to be really easy, just like with the last one. So, an example. For example, if we take 7 at first to the third power and then squared. This is something that we are going to do. Now, we are going to treat the 7 cubed, the 7 to the third power, as our new base of this exponential. Meaning, we are just going to raise this x to the second power. This is like x squared. Meaning, by the verbal definition, this is 7 cubed multiplied with itself 2 times. Meaning, this is 7 cubed times 7 cubed. Now you could go ahead and make use of the first exponentiation rule that we have derived, because we are multiplying exponentials with the same base together. They have the same exponent. It's really not a big deal. They can have the same exponent and you would arrive at the same result. But I would like to write everything out at first, just so my point becomes a bit more clear. So 7 cubed is by definition 7 multiplied with itself 3 times. So 7 times 7 times 7 times, okay, big times. And well, 7 cubed is yet again 7 times 7 times 7. All right, now we can go ahead and count. Well, how many 7s do we have? 1, 2, 3. I'm looking into the camera there. 4, 5, 6. Exactly. That was weird, navigating through my little mirror there, you could say. So we have 6 times 7. 7 multiplied with itself 6 times. Meaning, by the verbal definition, this is nothing but 7 to the sixth power, raised to the power of 6. Now, once again, we can immediately see something. We had 7 cubed as the base, meaning a to the nth power was the base. But the sub-base of this thing basically has been 7, or a. Now, just like with the last exponentiation rule, we basically preserved our main base that we had, a, in some way. We are going to get it out on the other side yet again. So what we can conclude is that a is going to stay where it is. Nothing's going to change there. Why would it in the first place, right? So that's a cool thing. First part done. Now we only need to ask ourselves how 3 and 2 are connected such that we can get 6 out of it. Well, 3 and 2 are actually just the prime factorization of 6. They make up the prime factorization. 3 times 2 is nothing but 6. Meaning we can conclude that 7 cubed and then squared is nothing but 7 to the 2 times 3th power, or 3 times 2th power. Multiplication commutes, we are going to talk about this in a second. Meaning, if we just compare exponents, basically, we have that our n was nothing but 3, it's going to be here, n, and m has been nothing but 2, n times m. So if we exponentiate an exponential, we are just going to multiply the corresponding exponents together. It's as easy as it is. Now, for another example, let's choose a big one. For example, 13 to the 16th power to the 6th power, 16th to the 6th power. Now we can just compare. What is our n exactly? Well, our n is 16, our m is 6, and our base is 3, our a. Meaning, our a is going to be preserved, it's 13, and we are just going to multiply the exponents together. 16 times 6. Well, 16 times 6 is going to be, so 5 times 16, 80. So, yeah, 96. 13 to the 96th power, and the calculator won't spit out anything. It's just going to spit out an error, basically, just because this number is growing exponentially. This is what you call exponential growth. It's just going to explode the higher you take this exponent up here. Okay, this is exponential growth, and it grows pretty hard if our exponent is greater than 1, just as a little side note. So it's really nothing special. It's as easy as it is. One little side note that we are going to make use of when talking about rational numbers later, being expressed as exponentials in some way. I have said before that multiplication commutes. So 2 times 3 is the same as 3 times 2. Let us rewrite this yet again. 7 cubed squared is the same as, let's compare m and n. This is 7 to the 3 times 2 power. Multiplication commutes. So I hope you agree with me that this is the same as 7 to the 2 times 3 power. And now we basically just interchanged the places of n and m. So this is just 7 squared raised to the 3rd power. And this is really important. That's a really important relationship, that since multiplication commutes, we can just basically interchange those exponents in some way. Keep this in mind, it's going to be important later in the game. Also, one more little rule that you can derive from it is if you have, for example, 3 to the 0th power, and then, for example, squared. Now, every a raised to the 0th power, except for a being equal to 0, is going to evaluate to exactly 1. And then squared. So 1 to the 2nd power, and 1 times 1 is simply 1. Meaning overall does make perfect sense, because this expression is nothing but 3 to the 0 times 2th power. If you don't have 2 apples, then you don't have 2 apples. It's just 3 to the 0th power. It's 1. And this holds for each and every a down here, not equal to 0. And this basically concludes this video. Hope you enjoyed this video. If you did, please like, subscribe, recommend channel if you like. Really important stuff. Going to be really extremely important later in the game. So please keep this in mind, especially for the fraction stuff. Yes, check out the main channel, support the channel on Patreon, whatsoever. Subscribe to this channel and the main channel, and also by those teachers I created. And up until the next video, I'm wishing you guys a flammable day. Ciao.